Good. Okay, so this video will be on exponential and logarithmic equations. Also, it's good to note that whenever you're solving exponential and logarithmic equations, sometimes there's only one way to solve them, and then other times there are multiple ways of solving the same equation. So we'll just go through a few of those different ways as we walk through the different examples that are put before us. So in the first example, we have 2 to the 3x minus 8 power equals 16. So that 3x minus 8 is the exponent. So what we can do here is express each side as the power of the same base. So we can use our one-to-one property. So if we can rewrite that 16 in terms of 2, then that would help us out a great deal. And we can do that. Notice the property is if I have b to the m equal to b to the n, then I can drop the bases and just have m equal to n. So I can rewrite that 16 as 2 to the 4th power. So that'll be 2 to the 3x minus 8 equal to 2 to the 4th. Now that I have the same bases, I can drop the bases, and that'll leave me with 3x minus 8 equal to 4. Now I can solve that as a regular linear equation, adding 8 to both sides, then divided by 3 will give me x equal to 4 as my solution. The next one, I have 27 raised to the x plus 3 power equal to 9 raised to the x minus 1 power. So I cannot change 9 into a power of 27 or 27 to the power of 9, but I can drop both of them to powers of 3. 27 is 3 to the 3rd power. 9 is 3 to the 2nd power. And also don't forget, whenever you're raising a power to another power, that's multiplication of those powers. So that 3 as an exponent would be multiplied to the x plus 3, and that 2 as an exponent would be multiplied to the 2 minus 1. So that would be 3 to the 3 times the quantity of x plus 3 equal to 3 to the 2 times the quantity of x minus 1. Now I can drop those bases of 3, leave me with that exponent of 3 times x plus 3 and 2 times x minus 1. Do my distribution. 3x plus 9 equal to 2x minus 2. Subtract 2x from both sides, and then subtract 9 from both sides, and that'll give me a solution of x equal to negative 11. Next one, if I have 4 to the x power equal to 15, I cannot break either one of those down to having the same bases. I can't turn the 4 into 15 or 15 into 4. So what I can do in order to have access to that x as my exponent, that's not 4x, that's 4 to the x power. I can apply the log, whether it's natural log or common log, to both sides. Applying the natural log to both sides, I just decided to use natural log in this case. Now I can bring the x down front by the use of the power rule. That'll be x times natural log of 4 equal to the natural log of 15. Now I can divide both sides by the natural log of 4. Natural log of 4 is just a number. So I can divide both sides by the natural log of 4. They will cancel out on the left, leaving me with x on the left, and then the natural log of 15 over the natural log of 4. Do not forget, when it comes to reducing, I cannot cancel out natural logs. The natural log is the application. So the natural log of 15 is a number. Natural log of 4 is a number. I cannot cancel out the natural logs and have 15 over 4. So the natural log over 15, natural log of 15 over the natural log of 4 is going to be approximately 1.95. Next one, I have 10 to the x equal to 120,000. In this case, I would use the common log because of the base of 10 that's on my exponent. It would be beneficial, or most beneficial, for me to use the common log. If I use the common log, apply that to both sides, the common log, and that base of 10 will cancel, leave me with just x. And then on the right side, I have the log of 120,000, which is approximately 5.08. Next one, 40 times e to the 0.6x. 0.6x is an exponent. Then minus 3. The minus 3 is not the exponent, equal to 237. So what I can do here is solve like I'm solving for x. I will go ahead and add 3 to both sides. So that'll be 40 e to the 0.6x equal to 240. Then I would divide both sides by 40. That would leave me with e to the 0.6x equal to 6. Now, just like in the last example, I would apply the natural log here because of my base of e. Before I used the common log because of my base of 10. This time I use the natural log because of my base of e. Apply the natural log to both sides. The natural log and the e will cancel on the left, leaving me with just 0.6x. equal to natural log of 6. Divide both sides by 0.6, and that would be x equal to natural log of 6 over 0.6, which is approximately 2.99. Next one, I have 5 to the x minus 2 equal to 4 to the 2x plus 3. Once again, apply the natural log to both sides so I can have access to the x's that are in the exponents. Doing that, that allows me to bring x minus 2 in the front. That'll be x minus 2 times natural log of 5. Bring it 2x plus 3 down front. 2x plus 3 times the natural log of 4. Distribute the natural log of 5 and the natural log of 4 into the parentheses so that we can have full access to the terms that involve x. So that'll be x times the natural log of 5 minus 2 times the natural log of 5 equal to 2x times the natural log of 4 plus 3 times the natural log of 4. Now, I want to get all of my terms with x on one side, all of my terms without x to the other side. So I'll subtract 2x natural log of 4 from both sides and add 2 natural log of 5 to both sides. That will give me natural log x natural log of 5 minus 2x natural log of 4 equal to 2 natural log of 5 plus 3 natural log of 4. Now I have all of my x terms on one side, all of my terms without x on the other. From here, I will factor out x from each term that has x. And then I will divide by the quantity that's attached to my x. So I have x times the quantity of natural log of 5 minus 2 natural log of 4. I will divide both sides by the natural log of 5 minus 2 natural log of 4. That will leave me with x equal to 2 natural log of 5 plus 3 natural log of 4 over natural log of 5 minus 2 natural log of 4. That is approximately negative 6.34. Next one, e to the 2x minus 4, e to the x plus 3 equals 0. Here I have a quadratic situation, or what I like to call a quadratic situation, in which when I look at e to the 2x, that's the same thing as e to the x squared. Remember, whenever you're raising a power to a power, you multiply those exponents. So that 2x is the same thing as e to the x squared. And then in my next term, I have 4 times e to the x. Well, if I decide to let u be equal to e to the x, that would give me u squared minus 4u plus 3, which is a quadratic equation. So I can go ahead and solve that as I would a regular quadratic equation. Factor the quadratic equation completely. That'll give me u minus 3 equal to 0. Well, u minus 3 times u minus 1 equal to 0. I can break it up now to solve u minus 3 equal to 0, u minus 1 equal to 0. Go ahead and solve that. That'll be u equal to 3 and u equal to 1. Now, remember, you didn't start off with u. Started off with e to the x. Substitute the e to the x back in for u. That'll be e to the x equal to 3, e to the x equal to 1. Apply the natural log to both sides so that my exponential part will cancel. So the natural log of e to the x will cancel out and just leave me with x. And that'll be x equal to natural log of 3 and x equal to 0. Don't forget the natural log of 1, or the log of 1 period will give you 0. All right. Next one, we have log base 4 of x plus 3 equal to 2. One of the ways we can write this one or solve this one is by rewriting it in exponential form. So remember, your base is always going to stay your base. So if I have log base 4, then when I go to my exponential form, I would use 4 raised to the second power equal to x plus 3. 4 squared is 16. Now I can subtract 3 from both sides. X will be equal to 13. In the next one, I have 3 natural log of 2x equal to 12. First thing I would do is divide both sides by 3 to get rid of the 3. And that'll be natural log of 2x equal to 4. Don't forget, natural log is the same thing as log base e. So I can rewrite that in exponential form. E is my base, so I can go e to the 4th power equal to 2x. Now divide both sides by 2 so that I can solve for x, and that'll be e to the 4th over 2 equal to x. That's my solution. All right, a few more examples, then we'll be done. Here we have log base 2 of x plus log base 2 of x minus 7 equal to 3. So I can use a product rule to condense this and make it one single log. So that'll be log base 2 of x times x minus 7 equal to 3. I can rewrite this using the exponential form. That'll be 2 raised to the third power equal to x times x minus 7. Now I can distribute x. That'll be x squared minus 7x, and then 2 to the third power is 8. Set one side equal to 0 by subtracting 8 from both sides. That'll give me x squared minus 7x minus 8 equal to 0. Now I can factor x minus 8, x plus 1 equal to 0. Set each part equal to 0. That'll give me x equal to 8 and x equal to negative 1. Now you should always check your solutions. If we were to go back and check these solutions, we will see that one would work and one would not work. X equal to 8 would work, x equal to negative 1 would not work. So the only solution we have here is x equal to 8. If nothing else, make sure you at least plug in your values to ensure that you're not taking the log of a negative value. Remember, we cannot take the log of a negative. If we just were to do that part, plug in negative 1, we would see we have the log of negative 1, which wouldn't work off the bat. So always go back and check your solutions. In this case, we see that our only solution is x equal to 8. Okay, last one. Natural log of x plus 2 minus natural log of 4x plus 3 equal to the natural log of 1 over x. So I can condense the left side by using the quotient rule, and that would turn into natural log of x plus 2 over 4x plus 3. Now that I have natural log of x plus 2 over 4x plus 3 equal to the natural log of 1 over x, I can use the one-to-one property and just drop my natural logs, and that'll leave me with x plus 2 over 4x plus 3 equal to 1 over x. I can cross multiply, take my denominators to the opposite numerators. That's x times x plus 2 equal to 4x plus 3 times 1, which is just 4x plus 3. Now I can solve the quadratic equation. Subtract 4x and subtract 3 from both sides to set one side equal to 0. That leaves me with x squared minus 2x minus 3 equal to 0. I can factor that x minus 3 times x plus 1, set each part equal to 0. X minus 3 equal to 0, x plus 1 equal to 0. That'll give me x equal to 3 and x equal to negative 1. Once again, we have two solutions, but only one works. So substitute it back into the equation, and we'll see that only x equal to 3 works as our solution. So let me know if you have any questions on anything I've said.